So I'm going to introduce the panel, Linking High Performance to Impact in Large Building Portfolios. Our moderator will be Don Coffelt. Don serves as the Associate Vice President for Facilities Management and Campus Services at Carnegie Mellon University. His 350-member team provides facility services, infrastructure management, utility operations, and auxiliary services required to support the university's 150-acre Pittsburgh campus. Reporting to the Vice President of Operations, Coffelt is also responsible for coordinating university-wide sustainability practices. Julianne Laue, is the Director of Building Performance for Mortenson and is responsible for executing energy and sustainability initiatives. With a background in mechanical engineering and emphasis on computational modeling, Julianne is dedicated to the design of low-energy and healthy buildings. She holds accreditation as a PE, Lead AP Building Design and Construction, BEPM, BEAP, and is a CSC, magazine's 40 Under 40 award winner. David Orr. David is the Paul Sears Distinguished Professor of Environmental Studies and Politics, Emeritus at Oberlin College. He also serves as counselor to the president of Oberlin College for 10 years. He is the author of 8 books, including Dangerous Years, Climate Change, and Long Energy, and Down to the Wire, Confronting Climate Collapse, and co-editor of 3 others. Rizwan Said is an energy manager for Allegheny Health Network. Said is responsible for network-wide energy-related activities, procurement, energy management, policy standards development, the Energy Efficiency Program, and Demand Response Program, and related services. Craig Stevenson, Eris Group. He is the president of Eris Group, which is a technology company based in Pittsburgh, Pennsylvania. Craig is widely known for his role in establishing Pittsburgh as a leader in evidence-based performance for the built environment. And Rob Campbell. Rob is a leader and co-founder of the Energy Network. Rob has 31 years of energy efficiency sector experience. He earned his MBA from the Tepper School of Business at Carnegie Mellon University. Thank you.
Thanks, Erica. We on? Yeah. Thanks, Erica. I'm happy to be here and thrilled to host this panel here for Energy Week. Normally, I'm not on campus this week. My schedule is a little bit different this year, and so I was really pleased to say yes when Anna asked me to come moderate this panel. As we talked this morning, the 6 of us, I'm really interested to hear. I'm hoping that we get off the first question because it took us about a half an hour to work through that one. But I'm looking forward to the panel and looking forward to what each of our panelists have to say this morning as we work through these questions. Our first question has to do with large building portfolios. Each of us has been involved in managing different types of large portfolios, and large building portfolio management is quite a bit different than other approaches to facilities management, especially with building performance. So I'd like to ask David Orr to get us started on perspectives for managing large building portfolios.
As it turns out, I'm the one person that doesn't manage lots of large buildings, so this will be very short. I think the issue for owners of buildings, whether universities or hospitals or public facilities, is what else can happen with these buildings. Our experience at Oberlin College in 2 major cases. One was the making of the Adam Joseph Lewis Center in the 1990s, which was the first entirely solar-powered, zero-discharge building on a U.S. college campus. That was a real learning experience. The college trustees had to understand not only the purchase price of the building, which came in at the high end of average for that particular building, but also the collateral benefits that came from doing something that was exciting and green and solar powered and so forth. So the collateral benefits included increased enrollments, increased philanthropy, increased publicity, and so forth. And you can put numbers on all of those things. If you run the film fast forward, The same has been true on the opening of an entirely solar-powered hotel and conference facility, 105,000 square feet or so. It was just named Platinum a couple weeks ago. And the issue for the college was what else happens because of this building? And what can we do with a conference center and facility that we couldn't otherwise do? And so the main concern I've had through this is how do the managers and owners of buildings learn through the process of design? The last thing I would say is that all architecture, in various kinds of ways, landscape architecture as well, is pedagogical. And that's a word I don't like to use much. It sounds like a foot disease. You know, do you have pedagogy? Yeah, but I'm taking something for it. It is instructive to boards of trustees and people that use facilities in ways that are deeply educational. And so the learning curve of people that own buildings, I think, is really critically important, and I'll stop there.
Thanks, David. And I also wanted to make sure that I got to Rizwan on this question, because as we were talking, I manage a portfolio of higher education buildings. His portfolio in the hospital network covers hundreds of buildings across many, many miles. My buildings are all sort of on the size of a golf course. So Rizwan, could you take on that question?
Yeah, thank you, Don. I mean, the basic principle is anything that you can measure, you can manage. I mean, so when I first started looking at a portfolio for healthcare, I'm looking for baselining those buildings to really understand or paint a picture of where they are, and any visibility, any data that I can collect is painting the picture of how can I manage these, where things fall in terms of understanding those buildings. Healthcare industry is so unique. Their number one priority is patient care, and it is our priority as well. But with that in mind, how can we manage these large building portfolio when we cannot measure certain things? I've seen in the past, I've seen systems with a lot of data available. Healthcare may or may not have the data availability because their priority is patient care. So I think baselining these portfolio are critical to really understanding where they are, and then and prioritizing them based on the bottom line, which impacts the bottom line. And if you ask me the question of bottom line to me is, hey, I want to reduce the consumption by 50%. But if you ask the same question to a different person in the organization, like a CFO, their bottom line is to reduce cost or improve operating efficiency. And if you ask the same question to an operator or an engineer, his bottom line is, hey, I don't want anything to go offline. I need this online. So it's kind of critical to really baseline these buildings, measure these buildings the right way, and prioritize them to see which impacts the bottom line. That's kind of key, the way I'm envisioning myself managing a portfolio of this size.
Thanks, Rizwan. I think that's an opportunity for us to transition to our other three panelists to consider this from a portfolio management standpoint. What initiatives and other considerations should be prioritized? Maybe Julianne, if you would kick us off.
Yeah, one of the things that I've noticed in larger portfolios is there's a larger audience that needs to be satisfied. Building operators, you're looking at lots more people in finance and trying to figure out and getting that alignment on what is the bottom baseline DNA of the company for the goals. So in healthcare, human health and wellness is a much larger priority. I say I teach a class myself, and I say to my students, healthcare is one of those places where I might give a little more leeway on energy consumption, because if the surgeon who's operating on me, wants it to be 60 degrees, have at it, So there are those kinds of considerations, and so there's a large stakeholder group, much larger too, when you start to look at the diversity of buildings within that portfolio, to really get this, not just a baseline understanding of the building, but a baseline understanding of the culture of the client that you're working with and the people that you're working with, to really understand what is success. And maybe success isn't net zero energy. Maybe success is different incremental goals and different headline stories. Maybe it's not LEED Platinum or an LBC building, but it's some other headline story that really gets to the core DNA of who that company or who that organization is.
Thanks, Julianne. Craig?
Thank you. Thank you. For us, it's about just talking to owners about what winning looks like. I think that's the biggest thing that everyone here is reinforcing is, what's the end game? What's winning look like? So it's very tempting for owners of portfolios of buildings to do something that gives them a little bit of flash or it gives them a bang and they feel really good about it by putting a PV array on the roof. But the question becomes, does it help us meet our goals? So for us, it gets back to the data side of things. We want to understand if we have campus-wide goals, then what are our building-specific goals? For existing buildings and new buildings, they are not necessarily the same because existing buildings has their own set of challenges and constraints that we have to deal with. So we want to use technology to say, what is the theoretical optimum that an existing building can perform at? Now we have a goal. And then we want to take that goal across all the existing building stock. Now we have a campus-wide goal. When we're building new buildings, it's really easy to build a passive house commercial building or a net zero building or a building built to any energy performance. Working with owners to understand what those goals are for new and existing, not just for energy, as we talked about backstage, but also for indoor air quality and environmental conditions. So we want to establish the right set of metrics for existing and new, take them campus-wide. Once we get there, then it's very easy to start talking about offset, whether offset's on-site generation through renewables or cogen or another system. Then we can start managing campuses holistically. Now, if you're like my friend here who's working for a healthcare network that has their buildings that are spread out, that offset might not be community-based, it might be more single building-based, but at least we can manage it.
Thanks. And Rob, if you could wrap us up on the priority question and then maybe help us transition to our next question, which relates to the differences between theoretical building performance and actual building performance.
Sure, thank you. So two things I think that are important in addition to what the panels has already said are making sure that the goals are aligned with the directives of the organization, making sure that you understand how energy efficiency impacts patient care, how it impacts client or tenant retention in an office building, how it impacts student enrollment and curriculum at universities, and making sure that there's an alignment to the goals of the energy efficiency programs that you're attempting to do with the alignment and the directives of the organization. And then secondly, I think it's really important to make sure that you have quick success, that you focus on those things that are visible to all the stakeholders that are going to provide you with the ongoing support of the programs, and to make sure that they have all of the impactful outcomes that you want, whether it's high efficiency lighting, it's a quick return on investment, it's addressing a research facility that generates a lot of revenue for a university, making sure that those opportunities that you start out with are ones that are aligned with the directives so that you can continue to get the funding that you need for your programs.
Thanks, Rob. And I want to come back to Craig on this question because we talked about it a lot this morning. It's so easy it's much easier to design for a high-performance building than it actually is to deliver one. And Craig's experience both in construction and building performance, I think, is perfect for this question.
Thank you. I love this question. So anyone who's spent 3 seconds in this industry understand that there's a complete disconnection from design and construction and operations. Design and construction, we design buildings, we build buildings, we turn them over to facilities and say, call us if you need us. And then they have to fix all the sins from design and construction. So what the goal here has to be is how do we connect design and construction to operations in a unique way so that building operators understand how buildings were designed and that they can operate them the same way. And to us, it's a technology issue, it's a data issue. If we're talking about smart building infrastructure and we're trending data using the building's performance, well, guess what? If we have an operational energy model, we have the simulation. Now we can start to get granular in terms of energy and environmental conditions to figure out how do we make a connection back to design and construction. Because at the end of the day, building owners are a little bit jaded over the last 10 years from promises made that weren't kept in terms of building performance. And when we want them to invest into a building's performance, we understand that there's a value prop there, but unless we provide a feedback loop to show them if they're winning or losing, then we can't regain that trust, and we have to figure out how do we regain that trust.
Yeah, thanks, Craig. Julianne?
Yeah, I'm going to argue the other side of the coin on that one a little bit. I think we've got a lot of great tools that are used in design and construction. There is a human aspect of that handoff from those teams, and also the involvement of the right stakeholders in the design process. A lot of times we exclude facilities management people in the design process, and hearing how the building evolves to where it got. We have goals in the beginning that evolve throughout the design process as construction and time constraints and funding and everything kind of comes online together. And so we do a lot early on design. I think there actually needs to be more time spent modeling, more time spent in design, and letting people utilize computational tools to come up with comparative analysis to really find those high-performing integrated pieces, and then take that, but make sure that the people who are going to use and operate the building, not necessarily every single user who's going to come in and flip on a light switch or use a space, but the people who are in charge of actually operating and understanding those buildings have to be along in that journey, have to be along in the commissioning process. If they're not with the commissioning agent, they don't know what got done. So it's really easy to point fingers backwards to say design and construction didn't get me what I wanted, but you don't know the reasons for that. So there's this whole communication and time piece that we all need to spend. And in my realm, I see so much, I gotta be in the building by X date. Gotta be in. And then we work the schedule backwards to the day in which the contract was initiated for the design team to start. And we cram everything in. And if you would have had one more month, what would you have gotten? If you would have had, that much more involvement from the operator side, what would you have received? So I think a little bit is in kind of almost, we're marrying an old process with new tools and new goals, and we got to rethink our human involvement in all of this, because computers aren't going to do it all for us, and data isn't going to do it all for us, because we got people.
Yeah, it's really interesting. We make the same mistake over and over again. We'll spend 3 years building a building that we're going to own for 100 years and worry about 30 days. Right. Yeah. So, Rizwan, we're talking about the difference between theoretical performance and actual performance. I'd like your perspective from the healthcare industry.
Sure. If I put myself into shoes of facilities, whether it's improper design, commissioning, we are left with those buildings to manage. So for whatever reason, to me, performance is dynamic in nature. Really need to understand how does the actual and theoretical performance behave with different variables. And understanding those key variables really give a perspective to what impacts the operations of my actual operations in comparison to the theoretical values. So I think a major amount of time is really involved in understanding those performances and the variables that impact that. Is kind of the key way to look at it. Hey, I'm left with this. I need to manage it. What's the best I can do with what I have?
Thanks, Rizwan. And David, I sort of saved you for last on this question, mostly because I wanted to also for you to transition us to the next question. I loved your story about the Oberlin's first green building. And the next question, so we're talking about theoretical performance and actual performance. And then the follow-up question is about value and communicating value in particular market sectors to leadership and value-based decision-making.
Well, first of all, on the second question, it's interesting because a new building is like a new technology. It's not just another building where things happen as they did before. It's different. So what we found on the Lewis Center, you're trying to calibrate this new thing with solar collectors, in our case, a living machine, and sensors, and all the things that now go into high-performance buildings, with a maintenance staff that wasn't trained to handle buildings like that. And so as you populate the buildings on a campus or in a hospital network or whatever with high-performance buildings, Then you have to change how the people who have to maintain them every day work. And secondly, you're trying to calibrate that with the expectations and behavior of the people who work there, whose offices are there or the students that are there. It's not just the same old kind of building. And if you have building windows that open and so forth and high performance HVAC systems and all that, then you're trying to calibrate that to the expectations, in our case, of a college board of trustees. And they expect their mentality about buildings is the way they used to work, what they used to be, where you had fossil fuels were cheap and you could burn them with impunity and so forth and so on. Climate change is not a real thing. And so, but to recalibrate their expectations about a building. And so there's a long-term process. On the Lewis Center, I think it took us 4 or 5 years to actually do that. And we found out that late in the design process from the engineering perspective, the engineers had put in a valve that only appeared, as I was told, in submarines to prevent cavitation. So that valve was closed. Once the valve was changed, the building worked rather better. I mean, it improved by 30% overnight. So there is a process of constantly analyzing things. And I think the expectations in all 4 of these cases have to be long-term. So you're expecting a building, as Stuart Brand once said a long time ago, and Vivian Loftus has said, I think, the same thing. Buildings have to learn over time, but that means the occupants and people who maintain them over time have to learn as well. On value, long story short, what we found in the Lewis Center, and I think also now in the new Gateway building, the Hotel Conference Center complex, is that you measure value in lots of different ways. And you measure value quantitatively and financially in one way. And then if you ask what happens in the world because we did a green building, high performance building, or whatever, well, then you have to add, what did the students learn from the process? Were they part of the design process? What are the students that are in the building for classes and the faculty in the building, what did they learn because they're in a high performance building? It's not like an old kind of building. What do you learn about finances, the finances of a building, and life cycle costing and the long-term benefits that go with having a green building? There's a whole different way to think about lots of things. You introduce high-performance buildings, and then you change, everything else changes. Finances ought to change, and the way we see the value of money. Admissions have to change, because admissions are going to go up. Exciting buildings tend to attract more students, and more philanthropy, and more attention, and so forth. So those are the collateral benefits. And they're very real. You can quantify them in some cases, and we try to do that, but they're not less real because they're hard to quantify. The last thing I'd say is this. History is going to look back and measure us, not by whether our buildings were green only. That's going to be very important. Carbon emissions are a major issue, and the biggest opportunity we have to offset or to avoid the worst of climate change ahead is to green cities and green buildings and so forth. But they're going to measure what happened in the buildings because they were green. And so this is where I think there ought to be a conversation, kind of a simultaneous conversation about green building and also curriculum, because they teach in all kinds of ways, and what happens in them is as important as the design of the building itself.
Thank you, David. Yeah, I don't know if you saw the head nods when you made the comment about you can't build a high-performance building if the operations staff doesn't know how to run it. Everybody in the room went, mm-hmm. That may be the bullet point takeaway from our panel. Craig, this question is about value related to building performance and how we relate that. It's essentially how we relate building performance to the portfolio mission. And how we communicate that to our stakeholders.
Exactly. And this was a really interesting conversation that we had amongst ourselves in the back, so I'll try to do it some justice here, is that if you look at the sustainable certification programs like Well Building, Living Building Challenge, they have plenty of white papers and evidence built around empirical data of benefits to occupants, right? So when you start talking about healthcare costs, production, presenteeism, absenteeism, churn rate. There's lots of data around high-performance buildings and its impacts to the occupants in that building. So when you look at it on a singular building basis, for us, it's identifying what the use is, who the owner is, and what they're doing within the building. If you're a school teaching, then you want to probably focus more on like CO2 and temperature and humidity, make sure there's a nice environment for them to stay attentive during testing and examinations. If you're in a hospital, it's probably going to be more around particulate matter and maybe VOCs, where you want people to, heal quicker and better, and they don't want to be compromised by poor indoor environmental conditions. So I think understanding use factors within a building. So the value prop then would be an energy within the building. There's a delta that's easy to calculate, and that's what everybody goes to first. But there's an occupant benefit that's a little bit more challenging to calculate, but I think it's rewarding if you can get your clients or your building's owners there, because the value of building occupants to energy is at least 10 to 1 in most buildings. And then there's an organizational benefit that David was talking about earlier that I don't know that you quite were able to articulate here because of time, but when you start talking about organizational benefit, then you're looking at throughput. If it's a university, right? Is it admissions or applications for admissions, and then acceptance and tuition and all that? So there's different key performance indicators that you want to look at on a micro level and a macro level, I think.
Thanks, Craig. And I don't know whether this is better for Julianne or Rob or maybe both of you, but to talk about, we talked in the back a little bit about there are things that you can quantify objectively, but there are intangibles as well that have these sort of more subjective benefits. To talk about how we value and communicate economic and ecological benefit. And at what point do we communicate those ideas to different stakeholders in the portfolio community?
I think that's a very important question. I'm glad you brought it up. Every one of us in this room has a different perception on what value is. Everybody here is either servicing a customer that has a portfolio of buildings, or actually is in charge of a large portfolio of buildings. And when you need to first understand what drives the value of those buildings. Why does an owner of those buildings want to make a building more high performing? For a commercial office building, it's to attract a certain type of tenant. The federal government, for example, has recently obligated themselves to only rent space within Energy Star buildings that have a 75% or higher level. Okay. For people in healthcare, it may be tied to average patient stay. As somebody mentioned earlier, the value for a school might be in standardized test results. Creating the environment, creating a high-performance building that actually creates the environment where students can perform better. So I think some of those things, some of those intangibles, there is market research out there now that continues to evolve to tie those intangible benefits to high-performance buildings. One of the things that healthcare is currently doing now is trying to value resiliency. When Hurricane Sandy swept the eastern seaboard and knocked out 2/3 of the hospitals for an extended period of time, there was a heightened sense of urgency amongst healthcare, but there was not enough emergency generators to back up the power that they needed to service the occupants. So they're starting to value and put a dollar value on the value of resiliency.
Yeah, I'm learning that I've had to begin to learn a different language. The language of the engineer and the language of data processing serves me well, but it doesn't take much to say to someone, do you want a green building? Do you want a healthy building? Do you want to save energy? Do you want to save the world? And everybody, yes, I do. But that board of trustees that you have to sell to, that you're going to get an hour here or an hour there, you're not going to get a half day to get them to a charrette to hear all of the great things they're going to do and all of these benefits. There are chunks of time that we get to sit with those decision makers to sell what we're trying to do. And that has been the language that has been challenging for me as an engineer to turn around and use, but also knowing that I now need to partner up with people in finance. Are there investors who want to invest in this? Are there ways that we could have leaseback programs with equipment? Are there PBAs out there? Are there different ways to engage these things so that they do get to move forward, not from an engineer's side or a facility manager's side or data processing or understanding, rating systems, but really on that business case side. So we're hitting those board of trustees, the CFO of an organization, and really going in to be able to sell the time and the money that it takes to institute these types of things, especially when we start to look at a portfolio-wide or an institutional commitment to something. That sales pitch isn't to the people who are in this room. I don't have to sell any of you on anything, but I have to sell people who maybe don't believe in climate change or don't believe in the same things that I believe in or have the same goals. So how do I put it in their words, in their terms, so that, yeah, it hits what you need to do? And that I think has been, kind of the biggest piece in moving forward is the technology's out there. Everything that Carnegie Mellon does around Energy Week and stuff, we can do it. We can do all of this. But we've got to get it out to the people who aren't on the same page as us.
Yeah, I mean, when we talked about this question in the back, it was interesting to see the spectrum of the decision-making process across various organizations, and sometimes how difficult it can be to get a decision made, even when the decision is obvious. Rob and I were talking about lighting retrofits, the easiest possible energy calculation to do, and still it can be difficult to get a decision made. And Rizwan, I was interested in your perspective on this whole stakeholder communication piece, maybe more challenging in healthcare than any other industry.
Absolutely, it's a mountain to climb. I'd say that. I think the biggest perspective is, the way I look at it is, there are at a given time 200 to 500 projects going on, and understanding the challenges and implementation are key to me. So, as you mentioned, the lighting project, why Allegheny Health Network, for example, still has fluorescent lighting. Why are we not doing those retrofits to LEDs or whatever? The challenge is not just, doing the job, solving the problem. It's understanding what's holding things up. If you look at, our hospitals and our clinics are ever changing. They keep changing, they keep modifying. The refreshes, the retrofits. We are doing what we can, but where the challenge is, should I invest the money needed now when I will replace that wing with something else? So the value is understanding the challenges in implementation. Because if someone is saying no to a certain project, there's a reason behind it. And to me, understanding those challenges, those criteria really help me align. Okay, I have a hospital of 2 million square feet. 40% of the areas are hallways and lobbies and offices that are not going to change. Why are we not doing so? So kind of taking those values and challenges and reiterating the value to prioritize certain solutions will drive towards high building performances, especially on the existing portfolio. If you look at all the new construction, new design, they're all compliant with the codes, which make them, more efficient relative to what the existing buildings are. But are they really pushing ourselves to a next level? We are, always engaged in looking at, cogeneration opportunities, things like that will, reduce our carbon footprint on the hospital network. And the resiliency that we get out of that is very critical, because now we have a hospital with 3-tier of redundancy to operate. That's kind of the key. Is it happening actively? Is it happening at every facility? No. That's the kind of objective. So the challenge and the understanding will give us the direction we need to really prioritize the value to who and how it can be objectively achieved.
David?
This is a kind of a footnote to a conversation, but for those of us who are old enough to have been around the green building movement for a long time and back to its origins in the early 1990s or before, one of the things that happened, and happened at a very granular level, happened in my experience with 4 different building projects, was what you really sold was excitement. And it is a devilishly hard thing to put a number to. But it's the sense in the room of kind of incandescence in the room, the excitement in the room as you take on a project. No one's done this before, or we've never done it this well before, or whatever. And I think also within the buildings, one of the things that happens in green buildings that I think, again, is hard to quantify, not impossible, but difficult to quantify, is what happens in a building built to certain kind of specifications. It's more beautiful, the light is more abundant, the white sound is great in the background, but things happen in those buildings that would not otherwise happen in simply a high-performance building. I mean, you can make a high-performance cinder block building, and it would be deadly. But what happens in green building, I think that's hard to quantify, has something to do with the spirit and the feeling that we're part of something bigger. And in a world on the threshold of massive climate change, the UN data, you all saw this last fall when it came out, we have maybe 12 years to deflect carbon emissions downward, and it's going to be a hard fight to do that. And it's not likely by most standards that we're going to do that. So we're at this transitional era at the big picture. And then the question is, what happens in these buildings that speaks to that larger challenge? It gives us not despair, but hope and that sense of excitement.
Thanks. And David, can we stay with you? I think the arc of your career has been pretty interesting, and the next question relates to high-performance building trends. So maybe you could just build off of your most recent comment.
Well, I never had a career, so I'm still planning to have one at some point, but I never had one. I got brought in, my training was in political science, international relations, and finance.
Once you figure out what you're going to do when you grow up, you'll let us know.
That's right, or
right?
I want to be a fireman or something like that. I think let me say, I don't know that this is a trend quite yet, but as background of this, I started a project 2 years ago called the State of American Democracy Project, and we did a big meeting in Oberlin in the Gateway Center in the fall of 2017. We have a book coming out early this next year, and then events across the country in lots of different ways. One of those events, or two of those events, one in Boston, one in Philadelphia, will be on urban design and democracy. And the Boston event will focus on urban design, sea level rise, and democracy. And so, two trends. I don't know that they're happening, but I think to some degree they are happening. One is to take green building to scale. When we started the Lewis Center in the 1990s, a little dinky building out in the middle of a cornfield, 14,200 square feet. And it did it well and so forth. The thing I'm most proud about is not the building, it's the effect it had on the students. But that was one building. Then we raised the ante to something called the Oberlin Project. Oberlin's a little town, center of Rust Belt, 35 miles west of Cleveland, 84 miles on a straight line to Detroit. We're Rust Belt. And so what we did was to wrap a line around the town and say, can you take the whole town to sustainability, green building, economy, and so forth? I think the two trends I want to propose, and I think to some degree they are happening, is to take green building to scale. So the green building becomes green design, and take that to the scale of whole cities. That's happening here in Pittsburgh. You've been a leader for a long time in that area, but it needs to happen everywhere across the earth. And that's a different set of design skills. It includes green building, high performance building, all the metrics that this panel has talked about and is so good at measuring. But to take it to that next level of urban design. And then the second trend, which I think we desperately need, is to marry design with how we conduct the public business. What is the relationship of the way we design cities and buildings and the way we conduct the public business in what is purportedly a democracy? I think a limited democracy and perhaps even a wounded democracy now. But to begin to engage a larger conversation, take the scale up and widen the conversation. Bill McDonough used to say, probably still does, that we're all designers in one way or another. So how do we design our cities and our planning and so forth? What's the relationship to the way we do the public business, even at the local scale, particularly at the national scale, and how we design and build? So those are two trends. Take it up to the scale, engage democracy and public planning and so forth, engage the public in what we do at that scale.
Craig?
From our perspective, we see one massive trend going on in sustainability for the built environment, and it's the prescriptive methodology from early lead through performance-based methodology through living building and well building and reset air to performance-based outcomes. That's the trend that we see. So when you think about that, we talked about this up here a couple times, but our job is not to design a great building. Our job is not to build a great building. Our job is to operate a great building. So when you look at that massive macro trend that's happening towards performance-based outcomes, then that's the suggestion, that's the recommendation that we see that the market's saying that we want our feedback loops, right? So whatever we're valuing within our buildings, and our clients are each specific in their value proposition, then let's make sure we have the right feedback loops in place to reinforce that the value is captured so that we can operate the buildings as they were intended.
Thanks. And I guess I'm looking at the rest of the panelists. Rob, you want to weigh in on that question?
Yeah, just one more thing we're noticing trend-wise in the industry is an occupant-based control. So when you think about a high-performance building, when you think about any type of building, they're living organisms that have people that work in them, and they exit and enter the building at different times, and they're not necessarily predictive. So with the advent of everybody carrying a cell phone around with them and being able to be identified, the building control systems now are evolving to a state where they'll turn the lights down if somebody leaves their office, or adjust the amount of outside air that is provided to the building if there's fewer occupants. So I think that the next evolution of really high performance buildings is going to be based on occupant control.
Thanks, Rob. Julianne?
Yeah, I'm going to weigh in quick. So one of the things that I'm seeing more of, and I'm not sure if the rest of the panel has, but it's this connection of the building design to the utility. So we're actually seeing more people design their buildings around both sides of the meter, what's upstream and downstream. Resiliency is a key piece of that, right? How resilient is my grid on this side? But understanding, I mean, I have owners now that want to understand what the utility rate structures look like as they're designing their building, and what peak demand management looks like, and integrating battery storage, and really looking backwards and holding the utility company responsible for a certain level of energy efficiency on their part, and being able to look at carbon neutral in the sense of how green is the grid that I'm buying from, and then how green is my building. So a net zero building, if it's getting renewable power from the local utility, can I take that into account? So really seeing this swoop that, yeah, there's the built environment, but it's connected to something much bigger. So really, we call it, both sides of the meter. So we're seeing more design of buildings that really are considering that.
Great. And so this thing is supposed to be giving me questions if you're submitting questions from the audience, but I'm getting radio silence. So I don't know if there's anybody on the technology side that...
I have lots of questions.
Okay.
Sorry you're not seeing them up there.
The voice from the sky. Hi, Anna.
Hi. Good morning, panel.
Good morning.
A couple of questions. So one for Julianne in particular. A little while ago, you spoke about energy efficiency and sustainability being engineered into buildings. How do you keep it from being value engineered out?
This is my pitch for truly getting a pre-design document almost, in which a lot of modeling and testing is done in order to truly integrate those pieces. If you're fully integrated, if you have a sustainability and energy conservation measure that really is a key piece that you don't want taken out, if you've got it so heavily integrated in the building design, if you take a cog out, everything else falls down. You're in redesign. Nobody wants to go there. So let's, get back, study it early on, get the financial metrics in place. It's all comparative at that time. You're not going to be able to totally predict what the, utility bill is going to look like in the future. But I mean, I have this huge push that I think we need to spend more time studying what we're actually building, and then really work on the construction documents. The CD phase of it and the building piece of it should be the easy part. I think we should be spending a lot more time with the technology and the information and the intelligence that we have on buildings, really getting those things so baked into a pre-design document that they can't be taken out. And again, too, though, working with the financial side of things so that the budget is right to begin with. If you start out and say, I want a 300,000 square foot building for $50 million, you're kind of locked into something. Have you even really studied the total need for the square footage? Or is the 50 million right? Or so I think there's just again, going back to my piece about, we say I need to be in by this date and I'm going to hire you on this date, but I didn't think about everything that has to happen in between. We got to take the time. If it's a 100-year building, why not spend an extra couple months in design to get it right?
So we got about 10 minutes. Anna, do you want to continue to feed us questions from the audience?
I do. So a question for Rizwan. How do you prioritize the health impacts of your buildings versus the cost of implementing energy efficiency?
I mean, the key is first baselining them, and obviously understanding where the baselines were, and then and benchmarking. Benchmarking. A lot of folks have big emphasis towards benchmarking where the buildings are. Now it's kind of a tricky question for healthcare. We have hospitals which are under the category of inpatient facilities. But if you dissect the hospital, majority might be not inpatient. So it could be a lot of clinics and doctors' offices. So benchmarking them with the finesse to kind of prioritize which building should be what. We have a network of 8 hospitals, and the age is all the way from 100 years, 100 plus years to the last 20 years, and the equipment has been upgraded, has been updated, but really the design is patched in, bandaged in. So I cannot just say, hey, my flagship hospital, which is 100 years old, should have the same EUI, which is energy usage index, as a new build. So to kind of standardizing them and benchmarking them is critical to understand which has the opportunity for better and improvement.
Yeah, it's interesting. I mean, we think, we design buildings for a particular purpose, almost thinking that they're always going to be used for that purpose. And if we're designing a 100-year building, it's almost certain that 100 years from now, we'll use it for something else.
I have a question that's related to that. Why should anyone be building buildings for only 100 years?
That's just a number, right? It's it's one significant figure, so I guess it could be any number up to 1,000 years. Where the Pantheon of Rome is 2,000 years old and still being used as a house of worship.
Yeah, one thought comes to mind is that it's very hard to predict what society is going to value a building beyond that term. There's a lot of, for example, 50 years ago, the concept of working from home was very foreign to a lot of people. So, we built these buildings, these institutions where people from 9 to 5 went and worked and came home. Now there's a lot of people that work from home. There's this thing called the internet now, which is, creating a lot of havoc for bricks and mortar companies like a Barnes and Noble or others that have often thought that I build more buildings and people will come. Well, now people are shopping online and they don't need to have environments or high performance buildings to go to. They can do all the shopping that they want from the high performance building that they live in. So I think it's a very hard question to answer, knowing how society has changed over the last 50 years.
I'd also like to add to that there's a sort of a running joke in the sustainable industry that the existing building is the most sustainable building there is, right? It's built, it's there. So when you have an existing building and you're looking at repurposing or refurbishing the unit, there are programs out there like a Passivos Enerfit program to retrofit, do deep energy retrofit for those existing buildings. So there are programs like that. There's empirical evidence-based programs you can use to retrofit existing buildings. But I think it's a really important question because the existing building stock, if we don't figure it out and we don't figure out how to deal with it from an energy perspective, we're never going to meet our 2030 goals. We have to figure out a way to touch the existing buildings, and we have to do it in a way that is compelling for building owners to make that investment and understand that there is an ROI on that investment, which we believe there is.
David?
That's a really good question, and you can spend a lot of time thinking about that. The problem of building has been, I think, that the expected lifetime of buildings is short, their environmental impacts are long. Carbon stays in the atmosphere for hundreds of years, thousands perhaps. And so we got to invert that ratio. The second thing I'd say is this. I think all of you that do design, building management, are in an amazing position to educate us about all kinds of things, including the longevity of buildings that are low impact and high performance.
Yeah, Craig's point was a really good one. I don't know it's got to be well north of 90% of all the buildings are already built.
I think the stats like 80% of 50 years or something like that.
Right.
Next question is, please discuss, or I'm going to add and talk about how you plan for building design and mobility. So transportation, location, accessibility, electric vehicle charging, et cetera. How are you planning and thinking about that?
So I'll start. One of the things that we've seen coming online is parking ramps that are actually designed to be something else in the future. It changes where the column spacing is. It changes how you get in and out of them. So, so for my clients, and what we're seeing is they're asking for things to be built to be something else in the future. And that comes at a city level, it comes at an organizational level, and then also this idea of the energy infrastructure coming in, being able to do electric vehicle charging, or how it changes, like parking is a big thing in transportation. So how people enter and leave the building and the design, really being a little more forward thinking, especially in larger cities, as to this is changing and it's changing so crazy rapidly that how does my design of something as simple as would be a parking ramp actually become something in the future without us having to tear down the parking ramp to do something else? So.
By the way, we have many, many more questions than we're going to be able to handle. Thank you, all of you, for all of your amazing questions. How are you considering distributed energy generation as a way of adding value to the building?
So I think one of the ways that distributed generation adds value to the building is in resiliency. So it provides a second level of power generation for, critical care type of facilities or any type of facility where you're using then the grid as a backup to the on-site generation. I think that's one of the major drivers that you see around the country now for customers who are looking at distributed generation. And the other, obviously, is the cost. So a lot of organizations, we were talking earlier around organizations focusing on their core competencies and wanting to maybe look at opportunities to outsource power generation, on-site distributed generation, facilities management, and focus on their core competencies. And in doing so, they're looking for ways that they can provide this resilient source of power net neutral financially.
I'd only like to add one point to that, is that the cheapest form of energy is the energy we never use. So if we can maximize our passive strategies first, recognizing that there's a natural order to sustainability, we want to drive consumption as low as we possibly can through strategies using building science. And then at some point, that distributed energy becomes much more smaller and easier to manage.
So to pile onto that, though, too, is there's two pieces to energy costs, right? There's your consumption, and then there's your demand charges. And as more and more utilities go into time of use rates, that's where companies and ratepayers can turn around and see that by having alternative energy solutions, that they can, yes, design right, save on their consumption, but then also be able to financially save on that peak demand charge. And so when you go back to talk to the financial people in the room, I can sell distributed energy generation and resiliency on peak demand and demand side management, especially looking as to where utilities are going with demand charges and how they don't like you to have demand, or if there's some place in an instance of a hospital where they don't have choices and when their demand is going to hit. So then you can manage, you're not changing how you're operating the building, you're changing what power you're using when. And so when we look at the financial savings that can come back from those sorts of things, you've got the resiliency piece also tied in with peak demand management.
David?
I'm into all the above. And just to add one other point, for us in a little town of Oberlin, small town, to do a building that was entirely powered by sunshine plus a surplus, and a hotel, 105,000 square foot similar, that changed the way the city and the community began to see renewable energy and distributed energy. So it was educational in that sense. It also was financially worked out, and the finances get better and better as the costs drop. But to do that in a place where, more so than even Pittsburgh, we're in a cloudy part of Ohio where sunshine is kind of a theory. I mean, we've heard about it and we've seen pictures of it, but to do it there, actually we're about as cloudy as most of Germany. But to be able to power buildings entirely by sunshine, and we're a net metering state, so you can drop power back into the grid and pull it back out at night. But that was really formative for the city. All of a sudden, and we're, you know, humans are, what's the ratio? 80% or some such number of our sensory apparatus is related to our eyes. So if we see it, we are more likely to believe it. And be able to see distributed energy in green buildings is really important as just a physical model.
I think we're going to get the hook. I knew this would be a great panel, and I knew we wouldn't have nearly enough time to address any fraction of the
Dozens and
questions that we'd
dozens of
like to.
Yeah, dozens of questions, dozens and dozens of questions. So we'll have them archived. And the good news is that I'm hoping that most of these panelists, if not all, will be available to talk during lunch casually. So that's the good news. Thank you, Dawn, for an exceptional panel. And thank you to all of the panelists.